I never do this. I've never done this in any of these videos. You know it, but these are extraordinary times, right? And so you might be watching this video some time from now, and what I'm saying now is completely irrelevant, and you're like, say what? But today, right now, is Friday, April 3rd. And Florida and Georgia just issued stay-at-home orders, and things are really different right now. And that's what gave me the impetus to go ahead and start making these videos again, so that everyone across the country doing Eureka Math can have a little bit more support. And so I have to thank my students, because they're awesome, and my children, because I love them. And I have to thank Grandma Nancy, who I talked to today, and her granddaughter, Ashlyn, is 9 years old and goes to Shady Hills Elementary in Newport Richey, Florida. You know, says that they really appreciate what I'm doing here. And I tell you, that makes me feel great. But I want to tell you that you can do so as well. So if you're talking to a classmate online, you can go and help somebody with their Eureka Math or whatever they're working on, or just give them somebody to talk to, because that's a great thing to have right now, isn't it? All right. So hi, Ashlyn. Shout out. Let's get to the math. It's lesson time. Yes, lesson time. Module 6, Lesson 4, more with the decimals. Let's see what we're doing. Meters. Remember the meter stick? I wish I had one. Yeah, meters, right? We're going to use a meter to model the decomposition of one whole, so think one whole meter, into hundredths. Those are the centimeters, okay, because there are 100 centimeters in a meter. Now this harkens all the way back to Module 2, which was quite some time ago, I'm sure. But there it is. And then we will represent and count hundredths. What does that look like? Like this. Okay. Well, there is a sprint on this one, so if you're going to do that, go ahead and do that. Pause the video, do side A, do side B, number correct on both, and how much you improve for side B. The idea of a sprint is running fast, like getting a little quicker at this, so it's becoming more of a intuition habit. So we're going to count by tenths. Here we go. 0 tenths, 2 tenths, 4 tenths, 6 tenths, 8 tenths, 10 tenths, 12 tenths, 14 tenths, 16 tenths, 18 tenths, 20 tenths. And we won't recount the whole thing, but you can see how 0 tenths is equal to the whole number 0, 10 tenths is equal to the whole number 1, and 20 tenths is equal to the whole number 2. Makes sense, right? Good. I hope so. Oh, knitting. Cool. Allie, knitting fiend that she is knitting a scarf that will be 2 meters long. Now that is a big scarf, because like that's a meter. Okay, and so like I can't even do 2 meters really with my arm, so that's a pretty good scarf there, Allie. Rock on, sister. Hopefully she's tall enough it won't drag on the ground. 2 meter long scarf. So far she has knitted 1 2/10 meters. Nice job. 2 questions. A, how many more meters does Allie need to knit to complete the scarf? We'll write the answer as a fraction and a decimal. How many more centimeters? Okay, so first we're doing meters. So the answer will be either a fraction or a mixed number. We're going to have a whole number and a decimal, okay? And then when we get to centimeters, that'll be how many centimeters. What does that look like? It looks like this. Let's do it. Okay, so the whole scarf is 2 meters. So your tape diagram is going to look like this. 2 meters is the whole thing. We know this part, 1 2/10. Ah, this is very familiar, isn't it? You know the whole, you know a part, there's an unknown part. That's why we draw these. So you can see we are subtracting to find the difference between what she has and what she needs. So we'll go ahead and do that. 2 minus 1 2/10. Well, let's think about that. How can we do it? That's right, we can decompose 2 as 1 whole and 10 tenths, because then the 1 minus 1 is 0, and then we just do 10 tenths minus 2 tenths leaves, right, 8 tenths. Okay, so she has 8 tenths of a meter. And is that a correct answer? 8 tenths meter? That is a correct answer. She has 8 tenths meter left. Now, when we get to part B, how many centimeters? We know that 1/10 of, this is actually an error. That should be 1/10 of a meter. And that's not my mistake. I copied that from Eureka, but it's my mistake in missing it. So I'm catching it now. Look, I'm crossing out that C. It should say 1/10 of a meter is 10 centimeters. Therefore, 8/10 of a meter is 80 centimeters. See, it's correct here, but it's incorrect there. I'll have to fix that someday. All right. So she needs to knit 80 more centimeters. So there are both answers. 8/10 meter, 80 centimeters. Nice job, Allie. Knit, knit, knit. Moving on. Now we're getting to the heart of the lesson. 1 centimeter. Here it is. Ready? 1 centimeter is 1/100th of a meter. Okay, think about that. I could do this in terms of money. 1 penny is 1/100th of a dollar. Isn't that right? There are 100 pennies in a dollar. 1 penny is 1/100th of a dollar. So 1 centimeter is 1/100th of a meter, which can be written as, either way, 1/100th meter. And, this is our first little gander at hundredths. Okay, so this first 0 is in the ones place. Then we have the decimal point, tenths place, and hundredths place. So this right here, this whole thing, we would read as 1/100th meter. Yes. Notice this, 1/100th meter in fraction. Tricky. Not tricky. Nice. There's a meter stick. What is its length? It's 1 meter. How many centimeters are in that meter? I just said it about 15 times. Yes, it's 100. Okay, so 100 centimeters. So 1 meter equals 100 centimeters. Write that, not on yourself, write it on something, or write it in your brain. Remember that. 1 meter, 100 centimeters. Okay. So a meter is made up of 100 centimeters. So what fraction of a meter is 1 centimeter? It's 100th. Yes, it's 1/100th. 1/100th of a meter is 1 centimeter. Getting it? 1/100th of a dollar is 1 penny. We see the connection with money, which we do make later in this module, but you'll see. So 1 centimeter is 1/100th meter. It's nice when we're dealing with ones, but you know I'm not going to leave it that way. No. All right, here it is as decimals now, or as a decimal. So 1/100th meter is 1 centimeter is 1/100th meter. 1/100th meter, 1/100th meter. Got it? The 1 is in the 100th place, so I read this number as 1/100th. Now again, I've mentioned this before, but just in case you're just getting on the bus, when we ask, how do we write this? That's when you would say 0.01. But if I'm saying, what's this number, or read this number, then you read it as a math number, you say 1/100th. Moving on. Now, let's do 3 centimeters. So we know that's going to be 3, right? What fraction of a meter is 3 centimeters? Well, if 1 was 1/100th, then 3 is 3/100ths. And here it is as a decimal. So 3 centimeters is 3/100ths meter. 3/100ths meter. Yes. How about 40? Oh man, way to go right to the double digits. 40 centimeters. It's going to be the same thing. Breathe. It's okay. 40 centimeters is 40/100ths meter. Is 40/100ths meter. 40/100ths meter, 40/100ths meter, also known as 40 centimeters. Make it a song. Send it in. You'll be a star. All right. Now, boy, I can't leave well enough alone, can I? Look at this here, 40/100ths meter. How many tenths of a meter is that? Well, if we were dividing this by 10 tenths to find an equivalent fraction, yeah, good thing you were paying attention then when we did equivalent fractions, because you need it now. So 40/100ths meter, yes, divide by 10 tenths, and you get 4 tenths. So 40/100ths of a meter would be 4 tenths. Think again in terms of money. 40 pennies would be 4 dimes. 40 cents, 40 cents, 40 centimeters. It all ties together. You have 10 fingers. Count them. So 4/10ths meter is 40/100ths meter. Great, and so on. All right. Look at this now. We can write 4/10 meter as a decimal or a fraction. These are all equivalents. I want to point out equals, 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 equals. These are all the same distance. If I said show me, this is, 40 centimeters. I said show me 40 centimeters, let's say about yay. And then I said that's 40 centimeters, okay? Then I said show me 4/10 meter, same thing. 40 hundredths meter, same thing. 4/10 meter, 40 hundredths, it's all the same thing. Bask in the glory of it all. Moving on. Now we're going to name hundredths as tenths and some hundredths, stating the number and fraction in decimal form, which sounds like, but again, we're going to harken back to money. Tenths are dimes. Tenths are dimes. There are 10 dimes in a dollar. Pennies are hundredths. There are 100 pennies in a dollar. So watch how this works in practice. Now we're going to be doing it with the meter stick, but I'm going to keep relating it to money because I find that helpful. So if I first measure 2/10 of this meter, 2/10 of it, and then another 5/100, okay, that's 2/10 of the meter and 5/100 meter. Well, we know from our work with fractions that we can't just like crash these together and call it 25 10,100ths or something maddening like that. We must do something. What is it we must do? Well, we have to think of them in the same terms. So look, I'll go back for a sec. 2/10, 20 hundredths. Do you see that? Because what we're doing is times 10/10 to find equivalent fractions. 2/10, 20 hundredths. Now we can just let worlds collide. 20 hundredths, 5 hundredths together is 25 hundredths meters. I bet we can write that as a decimal, can't you? 25 hundredths. You can write the number. Here's the trick. Write the number 25 such that it ends in the hundredths place. 25 hundredths. 25 hundredths. The 5 is in the hundredths place. So I read this number, 25. What place am I in? Hundredths. That's how you read those decimal numbers. And look at that. Zingo zango, just like that. Boom, you're on the problem set. Okay, and this is similar to what we did with the meter stick, except that I wasn't shading it in. We were just referring to the points on it, so it's the same idea there. What fraction of a meter is 1 centimeter? That's abso-smurfly what we were just doing, the exact same question. And here it is, dividing it up into 10/10. Yes, okay, or 10 hundredths, I should say, of the meter. Fill in the blanks. A tenth is how many hundredths? Again, think a dime is how many pennies. Here again, look. 1 dime is how many pennies? 2 dimes is 20. Yeah, you see how the relation to money works here? Think again here, it's a dime and 3 pennies is 13 pennies, is 13 cents. See how it helps you to use that relation to money, meters to centimeters, and just the raw numbers to help you understand this and do it. More of the same here, using the same directions from number 3 there. Okay. On this one, you're going to shade in first 8/10, 7 hundredths, 19 hundredths. Okay, so 8/10 is going to obviously be 8 of these boxes, right? Because there are 10 of them. When you do 7 hundredths, will you use even one box? No, because this is, we could call this a couple of things, but I can call it 10 hundredths, right? This is a dime or 10 pennies. It's 1/10. It's 10 hundredths. So 7 hundredths is not even going to be one box. Okay, so you will not go out, because this is an error I've seen, you will not go out 7 of these boxes. That would be 7/10, and this says 7 hundredths. Same thing here with 19 hundredths. There's 10, and then 9 out of 10 of this box. Obviously, you can't go out 19 boxes. That ain't 19. All right. Looking at this one, you're going to draw a number bond, pulling out the tenths from the hundredths. You know what number bonds look like, but you're going to say how many tenths. Well, we'll kind of do one orally together here. Look at 19 hundredths. So look at the 1 here. That's 1/10, right? We could call it 10 hundredths or 1/10. So I would draw out a line, say, hey, here's 1/10, and that leaves 9 hundredths. So the number bond would be 1/10, 9 hundredths. With that in mind, another way of thinking about it in terms of money, 1 dime, 9 pennies. 9/10, sorry, 1/10, 9/100. So same thing here, 2 dimes and 8 pennies, 7 dimes and 7 pennies, 9 dimes and 4 pennies. You get to exit ticket, it's the same thing, but in abbreviated form. And when you get to homework, hop on over to my homework time videos, because this is all the same stuff, but I walk you through each and every one of those examples one at a time in detail. And look at what you've done now. You've gone and completed yet another lesson time. Congratulations to you and I both, and to Ashlyn out there in New Richie, Florida. Keep the faith, sister, and I will see you all again next time. It is once again lesson time.